Welcome viewers. So here is another example under the sum of n term of a geometric progression. The question says the second term of a geometric progression is 2.5, while the fifth term is 5/16. Find the sum of the first 6 term of the sequence. Sum of the first 6 term of the sequence. So by definition, our Sn is given as a. This term, before we write the formula for the n term, we need to know the common ratio. So our common ratio will tell us which of the formula we are going to make use of. Now in this question, the second term is this. T2 equals to this. So we write T2 equals to 2.5. And that 2.5 is just 5/2. Also, in the same question, we have the fifth term is this, meaning T5 equals 5 divided by 16. And you know, when you are given certain term of a geometric progression, we know the formula for the n term of a geometric progression. So here we are going to make use of an n term now in order to know the value of first term and the common ratio. Once you know the value of first term and common ratio, you can generate all the members of such a sequence. Now, from formula, our Tn equals to AR raised to the power of n minus 1. Now, let's consider the first equation. We have T2 equals to 5/2. When n equals to 2, we have T2 equals A r raised to the power of 2 minus 1. That is AR. Meaning our AR equals to T2. And what's the value of our T2? 5/2. Meaning AR will be equals to 5/2. Also, let's consider the second one. T5 equals to 5/16. Now, it means when n equals to 5, we are going to make use of the same formula again. When n equals to 5 now, so we have T5 equals to AR raised to the power of 5 minus 1. 5 minus 1. That is AR raised to the power of 4. And what's our T5? 5/16. So this equals to 5/16. Now we know the value of the equation for the first one and the second one. Let's solve these two equations together in order to get the value for A and R. Now we have equation 1. AR equals 5/2. The second equation, AR raised to the power of 4 equals 16, 5/16. Now to solve for letter R, or to eliminate A from here, we have to divide the two equations. So once we divide equation 1 by equation 2, so we are going to eliminate A and we can easily solve for R. So let's do that together now. So now this divided by this. Okay, let me just rewrite. So now we have AR divided by AR raised to the power of 4 equals 5/2 divided by 5 divided by 16. So here A is gone, R here is 1, R here is 4, so one of the R will go, so you have just 1/r to the power of 3. Here also 5 will cancel out 5, and when 2 goes in 16, that is 8, so you have 1/8 here. From rule of indices, R raised to the power of 1 divided by R raised to the power of 4. That is just R raised to the power of 1 minus 4. 1 minus 4 is -3. And that is just 1/r raised to the power of 3. 1 divided by r raised to the power of 3. And that is what you have here. Here also, 5 over 2 divided by this, same thing as multiplied by 16 over, oh, sorry. There's error here. No, so 5 divided by 5 this divided by this, it's same thing as this divided by 5. So 5 is gone. This is just 8, so we have 8. Meaning 1 over r to the power of 3 equals to 8. Now from here, we can find the value of r. So our r raised to the power of 3 equals to reciprocal of 8. So that r equals to cube root of 1 over 8. So r equals to 1 over 2. Now we get the value for r equals to 1 over 2. Let's look for the value of a now. So let's make use of the first equation. Our first equation, we have ar equals to 5 over 2. Now we introduce r here. So this will just be a open bracket 1 over 2 equals to 5 over 2. Our r is half. This is a. Now multiply both sides of the equation by 2. By the time you multiply both sides of the equation by 2, we have a equals to 5. By the time you multiply both sides, we have a, or let's say a over 2 now equals to 5 over 2. So multiply by 2, multiply by 2. So 2 will cancel out the denominators. So we have a equals to 5. We know the first time we have the value for the common ratio. So we can easily find the sum of the first 16. Now, which formula are we going to use? So we are going to consider the formula when r is less than 1, because this half is less than 1, and that is Sn equals to a open bracket 1 minus r to the power of n divided by 1 minus r. So we are using this formula because our r is less than 1. R is less than 1. Now let's substitute the known values in the question. The question says find the sum of the first 16. So meaning our n equals to 6. A is 5, r is half, and our n is 6. Now we have S6 equals a, which is 5, open bracket 1 minus half raised to the power of n, which is 6, divided by 1 minus half again. Half raised to the power of 6, that is 1 over 64. So we have S6 again equals 5, open bracket 1 minus 1 over 64 divided by half, because 1 minus half is half. Again, let's take the LCM here. So this will be over 1. So you have S6 equals 5 is still outside. Now this is the same thing as 64 minus 1 divided by 64. 64 times 1. Everything over half. Again, we have S6 equals 5 open bracket 63 divided by 64. Multiply by 2 over 1 when you know this is fraction in denominator, so you just take the reciprocal. And from here, this is 5. Again, from here down, we have 5 multiplied by 63 divided by 32. No, these 2 goes in 64. That is 32. And we can multiply now. So our final result, S6, sum of the first 6 will now be 315 divided by 32. Why? Because 5 times 63 is 315 divided by 32. And this is the sum of the first 16 of this sequence.